In this video, we're going to talk about something called the fundamental principle of counting. What this means is if a sequence of several operations is to be performed, then the number of ways to perform the sequence can be found using fundamental counting rules. Basically, we multiply them together. So, for example, if I want to find out how many ways can I put 3 letters in any order, then what I do is I say, okay, there's 1, 2, 3 different ones that I want. There are 26 different letters that I'm looking at, and I do have to note that if I want the letters to be repeated or not. If the letters can be repeated, it'll be 26 times 26 times 26, which will give me that there are 17,576 three-letter words I can make if order does not matter. If order matters, or not necessarily order matters, but the letters cannot repeat, no repeats, then we're talking about the first one can have 26 different possibilities. Since I used one letter, the second one can only have 25 possibilities. The third blank can only have 24 since I used one letter in the first, one letter in the second, and one letter in the third. And so what this gives me is that if I cannot have repeats, that's only going to be 15,600 possibilities. And so this is what we're talking about with the fundamental principle of counting is how many options do you have for each possibility. So let's look at an example of possible meals. So the fixed price dinner at a Bouque restaurant provides the following choices. You have super salad for an appetizer, then you have baked chicken, broiled beef patty, baby beef liver, or roast beef for the entree, and then you can have ice cream or cheesecake for the dessert. Well, one way we can figure out how many different meals we can order is by doing a tree diagram. And so that's what I've started here, and I'm going to scroll up a little bit since it can't all fit on the screen. And what it is the first option is your appetizer. You can have either a soup or a salad. Let me try, here we go. I can fit it all on the screen here a little bit. And so the first option is you can have either a soup or a salad. For the entree, you can have chicken, a beef patty, liver, or the roast beef. And that's whether you get the soup or the salad. And so notice that I have the chicken, the patty, the liver, and the beef coming off of each one of those. Same thing happens with the ice cream and cheesecake. You can get that with any particular meal that you want. And so there's a lot of different possibilities. And so if you realize there are 2 possibilities for appetizers, there are 4 possibilities for your entree, and there are 2 possibilities for your meal. So 4 times 2 gives me 8, times 2 again gives me 16 different meal possibilities. And if you notice, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So even doing the tree diagram, I still come up with 16 different possible meals that I could order in this particular case. So what you're doing is you're taking however many that you have in each possible choice and multiplying it together. That is if you're selecting one item from each possibility. The other possibility is to look at permutations. Permutations is just another word for ordering. In other words, we've got to put things in a certain order. And so when we're talking about permutations, one of the things that we look at is factorials. Factorial has the representation of the exclamation point. This means factorial. And so if I do n factorial just means to multiply by the numbers itself and every number below it until I get to 1. So n minus 2 all the way down to 2 times 1. So I multiply all the way down until I get 2 times 1. So for example, if I want 4 factorial, that's going to be 4 times 3 times 2 times 1. So 4 times 3 is 12, times 2 is 24, times 1. So 4 factorial is 24. Now factorials become large very quickly because obviously you're going to be multiplying up very quickly as well. This is the number of permutations of n objects if you're taking all n of them. So I'm looking at 8 objects and I'm going to put all 8 of them in order. That's what a factorial is. Now the one that gives us the most trouble is a 0 factorial. This may be a rule that you just have to remember, and that's just going to be 1 in itself. Okay? So when we do want to know about a permutation itself, that is that we have our items chosen from n items, and we're putting them in order. So for instance, if I have 12 items and I want to put 4 in order. So my 4 is actually going to be my R, and my total is my 12, my N. Notice my N has not changed throughout this entire time. It's still my total that we're looking at. I'm choosing R, or 4 items in this case. And how we do this is we're going to have a formula called NPR. This means that I have n objects. I want a permutation because I'm putting them in order, and I'm selecting R objects. And the formula is n factorial divided by n minus R factorial. So the total number of objects that I'm looking at, factorial, divided by the difference between how many I've chosen. Basically, how many I have left over. Factorial. Okay? So let's look at an example of this. And in how many ways can horses in a 10-horse race finish first, second, and third? So my first thing is to figure out my total, my N. Well, my total is I've got 10 horses to select from. And I want to put them in order. The reason I know I want to put them in order is because first, second, third, the horse that comes in first could come in second, and that's a totally different order. And so my R here is going to be 3 because I'm looking at the top 3 positions. So we're going to have 10 permutation 3. And so we're going to have 10 factorial divided by 10 minus 3 factorial, which is going to give me 10 factorial over 7 factorial. So what this represents is 10 factorial is 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1 all multiplied together. 7 factorial is 7, 6, 5, 4, 3, 2, and 1 all multiplied together. Now if you notice, remember from days of fractions and simplifying, I can simplify all of these down, leaving me with just 10 times 9 times 8 for my final solution, which 10 times 9 times 8 will give me there are 720 ways that the 10 horses can come in first, second, and third. For larger numbers, you can solve it this way, or you can use on your calculator what is called the PRB button, your probability button. If you're using a TI-30X2S, which is what we usually recommend, you'll first type in the total number, 10, and then you'll hit PRB, and it will come up with a couple of different objects. You will underline the one that says NPR, okay, and then you hit enter, and then you will type in your 3 and then hit equals, and this should give you 720. If you have difficulties with that, let me know and I'll be glad to answer questions. Let's move on to another example with permutations, and that is the student council at a certain school has 10 members. 4 members will form an executive committee consisting of a president, vice president, a secretary, and a treasurer. What is the probability that Zachary is president, Yolanda is vice president, Xavier is secretary, and Walter is treasurer? Well, really there's actually only one way that this can happen, that these 4 people can get this order, get these positions. So I'm looking for this probability, so there's only one way that this can happen, but I need to know how many different combinations or permutations there are for a 10-member council to come up with a 4-member committee. And so that's going to be 10p4. So I'm going to have 1 divided by my 10 choose 4, which if I do that in my calculator or out on the side, I get 5,040. So 1 divided by this is going to be 0.0002. So the probability that Zachary gets president, Yolanda gets vice president, Xavier is secretary, and Walter is treasurer is 0.0002. So you can look for probabilities using permutations. You just have to be careful, make sure that they come up less than 1 and that they're never negative. Permutations are for whenever you want to look at the order. Combinations is whenever you don't care what order it is. We don't care what order we're looking at, anything like that. This is such as if I'm just selecting 5 objects out of off the shelf or something. It doesn't matter what order I select them, I'm just selecting 5 objects. And so for this one, it's going to be an NCR for combination. And it does change up our formula quite a bit. What it's going to do is n factorial over over r factorial times an n minus r factorial. So it's our total factorial divided by how many we're selecting factorial times the remainder factorial. And so remember that you have either those that you're putting in order or those that you're not putting in order. And so let's look at an example of this. How many different simple random samples of size 4 can be obtained from a population whose size is 20? When we're looking at simple random samples, it doesn't matter what order they're in. So we're going to take 20 combination 4. So that's going to be 20 factorial over 4 factorial, 20 minus 4 factorial. So that gives me 20 factorial divided by 4 factorial times 16 factorial. Now I can either write this out long ways, I can use my PRB button to get my factorials, or I can simply put this entire thing in my calculator at once as well using the PRB button. You should get that there are 4,845 different ways that 4 can be selected from a sample of 20, or a population of 20. We can also look at probabilities with this for combinations. 8 college students have applied for internships at a local law firm. 3 of them will be selected for interviews. 4 of the 8 are from Middle Georgia State College. What is the probability that all 3 of the interviewed students are from Middle Georgia State College? So here, what we're doing is we're wanting to know what the probability of this is. And so we want to look at what happens whenever we are identifying with our probabilities. And when we do this, we can identify it as the numerator is what we're looking at, which are those from Middle Georgia State College. So we have 4 of those, and we're going to choose 3 of them. The denominator is still our total number that we're looking at. So we have 8 students, and we're going to choose 3 of those. And so I have this denominator here, or this fraction here, and each combination is going to look a little bit differently. So my top combination is going to be 4 factorial over 3 factorial times 1 factorial. My denominator is going to look like 8 factorial over 3 factorial times 8 minus 3, which is 5 factorial. Well, whenever I do solve out the numerator, this is going to be 4 times 3 times 2 times 1 over 3 times 2 times 1 times a 1. The denominator is going to be 8, 7, 6, 5, 4, 3, 2, 1 over 3 times 2 times 1 times 5 times 4 times 3 times 2 times 1. And if I do some simplification here, notice that my 1, 2, and 2, 3, and 3 cancel, leaving me with a 4 in my numerator. On the denominator, these all cancel, and if I multiply this together, that gives me a 6, so that cancels, leaving me with 8 times 7. Well, 8 times 7 is 56, so 4 divided by 56 gives me 0.0714. So the probability that all 3 interviewed students are from Middle Georgia State College is going to be 0.0714. Notice I selected, okay, those from Middle Georgia State College. I had 4 of them, and I was selecting 3 of them. I could do this with multiple items that I've selected even. I just multiply the numerator. On the denominator, I had my entire group, 8, and I was selecting 3 of them. Now I want you to practice with combinations and permutations, and then let me know if you have any questions.